calculate the minimum speed in meters per second required to take an 84-meter radius curve banked at 11 degrees so that you don't slide inward, assuming there is no friction. So if you don't have any friction, you want to see at what speed you need to go when it is banked at 11 degrees. Right? It goes like this, right? The circle over which you're actually moving is horizontal. The center is somewhere there, right? But the road is banked like that, just like this. Okay, so we have to look at it. At some point here, the car is like that. The road is banked at the angle of like theta here. And find the relationship between the speed and the radius and the angle. All right, let's go. And then we can actually find the minimum speed and maximum speed for each banked curve. If there is no friction at all, there is a specific speed you need to go on a bank. But if there is friction, did I say friction? If there's no friction, there's a specific speed that you have to go. But if there is friction, you can go a bit faster or slower. All right? The question is, given that you have a coefficient of static friction, what is the maximum and minimum speed that you can go on a banked road? Okay? Then, when there's no friction, then you just put mu equal to 0, get the result of this. But we can do that first. Let's do that first because it is easier. All right. As I said, we do it this way. Okay. So we're looking at now the road is like this. You're looking at it from front. Okay. The road is like this, banked at angle theta, and the car is going on a horizontal circle. So this is the surface of the road, and it is banked at this angle theta, let's say, to the horizontal. And the car is like this. There are the tires, and this is headlights. It's coming at you. And the car is rolling his eyes. Something. All right, so what are the forces acting on it in this case? No friction. What are the forces?
Normal force.
Normal,
weight.
normal and weight. Yeah, normal force is like that, perpendicular to the road, and the weight is like this. Right? What is the free-body diagram? For free-body diagram, you need a coordinate system. Which direction do you take coordinate system?
At an angle.
At an angle like that?
Yeah.
Yeah, which direction is acceleration?
Going that way.
Which way? That way.
Oh no, sorry, the opposite way.
Yeah. It's going, this is the center of the curvature, right? And the acceleration is toward the center. So which direction do you think we should take there's acceleration this way, right?
So
Say if there's acceleration, that direction would be good direction to take in one of the axes, right? So it's good to take the horizontal as x-axis and vertical as y-axis. And then W will be downward, the weight, and And normal force which will be which way?
At an angle.
Perpendicular to the, it will be like that, right? What is the angle? The angle to the y-axis is what?
11.
That's theta, right? Let's do it in general. And then the acceleration is in this direction and has a magnitude v squared over r. Right, there's no friction. So if we do sum of fy equal to may, what do we get? Sum of fy equal to may, because a is in the x direction, ay is 0. And sum of fy is just n cosine theta, right? Minus mg. And cosine theta minus mg equal to 0. So n, this gives you n cosine theta equal to mg. Doesn't give you, it just basically gives you the magnitude of the normal force. And then if you apply sum of fx equal to mas, which is equal to a now. So what do we get? How many x components do we have?
Just one.
Yeah, just n. What is the x component?
N sine.
N sine theta. So n sine theta equal to m v squared over r. What are we looking for? Here we're looking for v, right? And n is unknown. We can divide to get rid of n. If you divide equation 2 by equation 1, so 2 divided by 1 gives you what? Get n sine theta over n cosine theta equal to m v squared over r divided by mg. N cancels out, so the mass of the vehicle doesn't matter. N cancels out, so it gets tan of theta equal to v squared over rg. So v squared is equal to rg tan of theta. Yes.
Wait, why do we put 2 over 1 again? The equation 2 over equation 1?
Because I want to get sine over cosine and cancel. Sine over cosine becomes tan. That's why I do 2 over 1. If you do 1 over 2, you get cotangent of theta equal to inverse of this, which is the same thing. But we want to use tan because it is right on the calculator.
Well, I mean, why do we do that though?
Because we want to get rid of n. We want to solve for v. But we don't know n. You could put n from this equation into this equation. You get the same thing. You get mg divided by cosine. You get mg divided by cosine, and it cancels. Then you get sine over cosine becomes tan. You get basically the same thing.
Well,
Yeah, it doesn't matter how you do it. It's just the fastest you can do it, the better it is. Okay? Alright, so you get this. You can calculate the number. The number doesn't matter. Now we want to see what if we have friction. If we have friction, we have a minimum speed, we have maximum speed that we can go. What is that minimum and maximum? Suppose
Well, we have to find,
the road is banked at angle theta, and there is a static friction coefficient of static friction mu s. What is the minimum speed and maximum speed that you can go on that road without slipping? There's a minimum speed because if you go slower than that, you will slip down. There's a maximum speed because if you go faster, you will slip up. So there's a minimum and a maximum.
so this would be the minimum?
This is both minimum and maximum because there's no friction.
Oh,
This
okay,
is the first precise speed that you need to go. But I'm saying you can go ahead and answer this question by doing the friction. But I'm asking more general questions.
Yeah, okay.
If there is a friction, what is the minimum and maximum speed you can go? And that's very interesting.
So we just,
Problem.
we would just switch the frictional force for the maximum.
That's right. That's right. All right. Let's say there's friction.
Okay.
If you go fast, then the car tends to slip up, the friction is downward. If you go slow, the car tends to go down, the friction is upward. All right? So, now we can do the free body diagram with friction. Let's say the friction in general is this way, Fs. And then this is also the surface of the road. So the friction will be this way, Fs. And this angle is also theta. Alright? So let's see what happens if you have friction. Keep that in mind. The equation becomes similar to that, but with very interesting result. I haven't seen that in any book.
What?
Actually, I haven't seen the solution of this in any
This
book.
problem?
This problem that I'm presenting right. Actually, I haven't read all the books, but I haven't seen this. All right, what do? As usual, we have free body diagram. Sum of fx equal to ma, sum of y equal to ma1. Because the acceleration is in the x direction, we do sum of fy equal to 0. So sum of fy equal to ma y, which is 0. What is sum of fx? Sum of fy, sorry. Sum of fy is n cosine theta, right? So we have n cosine theta. What is the y component of fx?
Sine.
Sine later.
But it's negative, right?
Yeah.
Negative
Minus.
fs sine theta and minus w minus mg, let's say, equal to 0. That gives us n, and let's leave it like that. Okay. That gives us some information about n, right? Complicated. But you see, it gives us some information about n, and it is related to fs also, right? With the speed, if you change the speed, fs changes, n changes, everything changes. And so that's a little bit tricky. That's why you have to, if you don't act systematically, don't just write equations, see what gives you. It is not a matter of plugging in numbers and calculating something. It's not. All right. Keep that in mind. We will see the result of this is interesting. All right. By the way, is the writing is visible in the video? I think it is.
Yeah, it's visible.
All right. What is sum of fx equal to max? W doesn't have x component. We have x component of normal force, which is normal times sine theta, right? Because it is not adjacent. So normal sine theta. What about fs?
F cosine.
Fs plus fs cosine theta equals to m times
B squared over R.
all right? That's all we have. So from here, how can we find minimum speed, maximum speed? Okay, look at this. If the speed goes higher, friction has to go higher and n has to go higher. Right? Because from here, if you move this over, mg is constant. Sine, cosine theta, and if n goes higher, fs goes higher. Right? So this fs, when you increase v, fs increases until it gets to what? Fs max. By which you can write mu s times normal force. Right? So I'm going to switch v to v max and switch fs to fs max, which is mu s times normal force. So when v is equal to v max, fs is equal to fs max, which is equal to mu s times normal. So I rewrite both of these equations with that. Okay, so here we get n cosine theta minus equal to, minus better, minus mu, fs becomes mu s times n. So it becomes mu s times n sine theta equals to mg. I move the mg over. And this one becomes n sine theta plus mu s n cosine theta equal to n d squared over r. Right? With v max squared. V max squared over r. And then you see I don't need normal force. I want to find this v max. And if I divide these two equations, n cancels out. Right? Because it has both n here. M cancels out, n cancels out, and what do we get? We get v max squared over rg here. If we divide, now call this equation 1, equation 2. Right? We have these two equations. Divide equation 2 by 1 because we want to find v max. If you do that, n can be factored and cancelled. All right? So it says we get sine theta plus mu s cosine theta. On the other side, we get v max squared over r divided by g. So v max squared over r and g. On that side. On this side, we get sine theta plus mu s cosine theta divided by cosine theta minus mu s sine theta. Right? All right. Does it mean anything to you? If you know good algebra and trig, it should mean something to you. Let's divide both numerator and denominator by cosine theta to get tan. All right? So this, you can divide both numerator and denominator by cosine. So you get tan theta plus mu s divided by 1 minus mu s tan theta. Does this ring a bell in three? What if mu s? Remember we said that if you keep raising the angle, at some point it starts moving. At some angle. What was that angle? You keep raising it. There's a static friction, right? When it starts moving, there's an angle. What is that angle? You remember? We said tan of that angle is the mu s. If you go back, so let's take a theta where tan of theta is mu s. So we call mu s equal to tan of theta s. That is when you tilt the slope until it starts moving. That's just a number. Instead of mu s, I want to write it in terms of theta s. And if I write tan of theta plus tan of theta s divided by 1 minus tan of theta s, what do I get? Remember 3? So V max squared is equal to Rg times, this is tan theta plus tan theta s divided by 1 minus tan theta s. Oh, I could do it differently. That would be too much. Remember this from trig? This is tan of theta plus theta s. So V max squared is Rg tan of theta plus theta s. And V max is the square root of that. Remember, it was without friction, it was Rg tan theta. I just add theta s to it. Okay, so V max is square root of this. What about V min? Minimum speed. What happens if you go slower? If you go slow, you tend to slide down this way, so friction is another way. Right? You do the same thing, you flip the sign of that. You flip the sign of this. And here, flip the sign of that, flip the sign of that. Here, flip this sign, flip this sign, flip this sign. Flip this sign becomes V min RG tan of theta minus theta s. So minimum is square root of RG tan of theta minus theta x. Isn't that pretty? What does it mean? What if theta s is the same as theta? Or theta s is bigger than theta? The under square root cannot be negative. Means that there is no minimum. You can stop there. Right? You can, this is the car, it's banked, there's not enough angle, you can stop there, you don't need to move. What if theta plus theta s is more than 90 degrees?
Well, then you can go and back speed. Or
No. What is tan of 90 degrees? You remember?
Zero.
Tan of 90.
0?
No. Sine of 90 divided by cosine 90.
Oh,
What is cosine 90? 0. Number divided by 0. Infinite. Right? So it means that if theta plus theta s reaches 90 degrees, then you can go as fast as you want. The Vmax becomes maximum because it becomes infinite. There's no speed you can go at to slip out. Have you seen the motorcycles that go on walls,
Yeah.
turning around? So when theta is 90 degrees, this is already more than 90 degrees. You can go as fast as you want, you don't slip out, that's obvious. But you need a minimum speed to keep on the wall. Right? You see, when you solve a problem like this, it's a little pain, right? A lot of algebra. But then you get some insight. You look at it, you can take information out of it. The things that it not asked ever, it never asked before. You can answer questions that are never asked. All right, that's why a real physicist, a real engineer does things like this. It's not just plug and chug. Plug and chug is just it's no fun. It is, yeah, you have a problem, you find an answer. And then you never see that problem again. What did you do? There's some practice to it. Okay, it's good. But then you do it this way, you answer a lot of questions. And again, what if there is no friction? Nu s is 0, but theta s is 0. What do you get when there is no friction? But V should be Vmax and Vmin are the same and becomes the square root of Rg tan theta. So this is the prettiest problem that you can get in Newton's law. Of course, I have some other that are also pretty. All right. So now you can answer this question. What is the minimum coefficient of friction needed now? For the frightened driver to take the same curve at 15 kilometers per hour. Now it says there's a minimum friction needed. And so you can put the Vmin at 15 kilometers per hour and calculate that. So we answered that question already.